So when I think of a wave, I'm usually thinking about the ocean or another body of water where this big body of water is pushing things around, right? Maybe you can surf on it. Um, maybe you can, use it to move things. Maybe it pushes your boat. Um, but I'm thinking there might be waves that are in other places. Maybe there are waves that aren't in bodies of water. So take a moment to think about that. See if you can think of any examples of waves that aren't in bodies of water. Okay, so now that you've thought about that, I want to talk about what actually is a wave and why do we care, right? So that's going to be the subject of this little brief discussion: is what actually is a wave, and why on earth do we care what a wave is? Because that's going to be the whole topic of this whole unit. So this better be important, right? So waves are propagating energy. um, I'm going to show a brief video to show what this means. So let's look at this video here. What this is a bunch of they're doing the wave. This is a classic thing. Remember back when we used to go places and be near people, this is an activity you might have done. What's happening is every time the person next to one of these people stands up, they stand up and then they go woo and they sit down. Okay. So this wave gets passed around the whole stadium. What's important to note here, though, right, is none of the people move side to side. The people all stay in the same place. They just stand up, right, just, woo, and then sit back down. Okay, so that's sort of interesting. So that's really, I think, shows what a wave is. What a wave is energy moving from one place to one another. In this case, that energy was that people going up and yelling woo. Um, they're propagating energy. There's a pulse in a direction. The matter might move slightly. So the matter in this case is like the people, right? They're moving up and down, but they don't propagate. They don't do that thing where they move in a given direction. Let's talk about what propagation means. So propagation is a tough word, and it's one you're going to need to know for this class. Propagation means you're continuing moving in a given direction in this case. So if we're going to propagate a wave, it means you're going to move in, like you're going to actually move over space and you're going to stay moved over that space. You're not just oscillating back and forth between 2 points. Like so right now, my finger is what we call oscillating. It's moving back and forth between up here and down here. Right? It's oscillating. Now it's moving, it's propagating across. All right, so there are 2 types of waves we care about. The first one is going to be a transverse wave. I'll show a brief video of what a transverse wave looks like. This is a dude doing a workout. What he's doing is he's lifting and he's moving these ropes, right? You'll notice that the rope doesn't propagate, but the wave propagates along the rope. And this is called a transverse wave. It's called a transverse wave because it's moving up and down. The matter, right, moves up and down. It's moving perpendicular. Perpendicular is like this, right? It's moving perpendicular to the direction of propagation. So that's a really important term about transverse waves is that the matter is moving up and down, which is perpendicular to the propagation. All right, a couple of terms about a transverse wave that you're going to need to know. So the amplitude, that is how high each one of these waves goes above like a normal set. So you can imagine, right, if we have something right that is flat and normal, right, then I move it, right, I'll give it a thwack. Its amplitude is how high I might move this. When I jump it down, having trouble making a good wave in these headphones. The amplitude is the difference between the top and normal. There are 2 terms that have to do with amplitude. There's the crest, this is how high the peak is, and the trough, which is how low the bottom part is. The crest and the trough are going to be the same distance from the middle, and that's going to be the amplitude, is the distance to either the crest or the trough. Another term that's going to be important is one wavelength. So a wavelength is the distance between one crest and the next crest. You also can measure it as the distance from one trough to the other trough. That's going to be the same distance. So these are all important terms in a transverse wave. And then you're also going to want to know the direction that a wave is traveling. Transverse waves are awesome. They're all over the place, right? Waves like what we're thinking about initially, right? These are transverse waves. You can see the propagation of high points and low points. They're going to be really important when we're thinking about day-to-day life, especially if you're thinking about mediums that have these, right? So if you're thinking about trying to build a safe building near the water, right? Right now, when I'm recording this video, the river downtown is all flooded. We need to think about how buildings will survive when they get hit by a wave. Just one example. We have another type of wave, though. And this is possibly the more important type of wave, I think, and sort of the wilder one. This is called a longitudinal wave. And you're going to see a different process here. I'm going to show a quick video of a longitudinal wave and a slinky. And so what this guy is doing is he's putting some compression into the wave. And you see that there's this pulse of compressed slinky that moves down there. There's this compressed area and this rarefaction area. But it doesn't move up and down. There's this like compressed pulse. This is why we also call this a pressure wave. So what's interesting here is the medium, right? The medium here in this case is the slinky. Medium is just the stuff through which a wave is moving. So that's going to be an important term to know. Is the medium is the stuff through which a wave is moving. It could be something like water. It could be a rope, or it could be a slinky. And medium is moving left and right, but the propagation is moving in the same direction in the longitudinal wave. So is moving just to the right. So we're seeing this the movement of the medium and the propagation of the wave are parallel in longitudinal waves. So we have parallel movement and propagation, and then we have perpendicular movement and propagation. Important stuff. Now, these are the waves we probably care about even more. So we're going to talk about this a lot in the next upcoming week, but longitudinal waves include things like sound waves, which are compression and release of air. And that's going to be really important to understanding of how we do like sound design, how we make speakers, and like why the Doppler effect works. So that'll be interesting. All right, thanks, y'all.